Hi everyone. Section 1.3, hopefully you'll mostly feel like just continuing to practice the stuff you've been doing. There's a little bit of new concept in here, but the work should feel really similar. So I'm hoping that'll give everyone a chance to kind of settle in with all the mess that we've been doing and feel comfortable. What we're doing here is looking at ways to combine functions, mostly two functions, but it could work on more than two. And we're going to come back to this a little later in the quarter, so this will be kind of a nice warm-up for composition that we do later on. We're going to look at combining functions by adding, subtracting, multiplying, and dividing. And what we really want to focus on, actually doing that's very simple. Adding two functions just means adding their outputs, so it's nothing too tricky to do. But what we want to focus on is the fact that when we do combine two functions, we end up with a new function, and it's its own function. So yes, we got it by adding f and g, for example, but it is now a new function called f plus g, and it will have its own domain as well. It potentially could match up with f and or g, but not necessarily if f and g have domain restrictions, unless they're the same domain restriction. F plus g is generally going to have a different domain than those two. So to emphasize that, we're going to use some notation. It's nothing very big, but if we want to talk about, oh, my pen's not writing. Hold on, let's see. Pen, there we go. The addition of two functions, we're taking function f and we're adding it to function g. We're going to call the resulting function f plus g. So rather than emphasizing over here in number one that we are plugging the input into two separate functions and then adding, in number two we're emphasizing that we've created a new function f plus g by adding, and we're now plugging our input into that new function. Similarly with subtracting functions, with multiplying functions, I've been seeing a lot in the stuff that I was poking around in for ideas of this using the dot for multiplication, but I'm also know, even though I didn't spot any of those, that there are books out there that'll just write FG next to each other the way we do for multiplication in mathematics sometimes. So either one of those works for the product of two functions. And then quotient as well. So for dividing two functions, we get this f over g, which you don't have to write as a slanty fraction like that. You can write it as f over g of x. Up to you. It doesn't really matter. So whatever you like there. And in terms of the domain of this new function, generally it just boils down to looking at the numbers you can't plug into f and the numbers you can't plug into g and saying, okay, well then we certainly shouldn't plug those into f plus g or f minus g or f times g. The one that's slightly different is f over g. We will be building a fraction into something that might not necessarily have had any fractions. So we will have to worry about making new problems with dividing by 0. So for f divided by g, we'll want to leave out anything that causes problems for f or g individually, and we'll also want to leave out anything that causes g to be 0 and would make that new fraction undefined. So that's kind of the background info stuff. I think I'm just going to keep this one short and keep examples separate, but that's what I want you to be thinking about as you go through all of this. Like I said, hopefully the actual work won't feel too bad, so just keep thinking in your head about the fact that what we're trying to emphasize here is that when you put these two functions together, you now have a new function with a probably new domain, and if that's in the back of your head, then you'll be getting good prep for when we do a little bit different version of this later. Okay, thanks for watching.